Okay, so creating quadratic equations from information. So in order to do this, we need to kind of know our three major forms of quadratics. We have the vertex, the factored, and the standard form. And when you're given information, it's usually the vertex or the factored form that are easily or the easiest to make right off the bat. I can barely think of any coordinates where it'd be easiest to build standard form from it. Okay, it's usually easiest to build vertex and factored, and then if you need it in the standard form, you do some kind of conversion from there or to there, depending on which is easier. It's easiest to build vertex form when given the vertex. Kind of makes sense. And the vertex are actually the h and k values here. Okay, it's actually the opposite of whatever that h is in there. Okay, and whatever the k value is, it's what that is. And sometimes it's represented as a negative. Depends on how you think of that h. Factored form. Factor form is easiest when you're being given x-intercepts. Okay, intercepts. There you go. That's because the r and the s value are essentially representing an x-intercept where a parabola crosses the x-axis. Okay. Standard form, the one coordinate that's really helpful is the c is a y-intercept, but doesn't give you a lot of info about how to solve a and b. Hence why standard is really hard to make. So, in this question, we're actually really lucky. They give us the vertex, and they give us the x-intercepts. So, I actually have a choice. I can decide to build in vertex, I can decide to build in factor. They're both relatively simple compared to each other. Again, standard hard. We'll maybe just extend that idea. So, let's start with vertex form. Let's take the vertex and use that information. Like we said, this is the h value, and this is the k value. So, vertex form being that f at x is equal to our a x minus h squared plus k. Okay, so here's the h, here's the k. We're going to simply substitute those values. That 5 goes in here, and that negative 12 goes in for the k value. So we now have f at x is equal to, I'm just going to write this in black now, a x. This will become negative 5, so it's opposite, okay, that idea. And this stays as negative 12. Great, we're almost done, minus we don't have an a value. Okay, so in order to really find the vertex, you need the vertex and you need another coordinate. Okay, luckily they've given us 2 other coordinates. I can choose either one. Okay, though they didn't write the entire coordinate out, if this is an x-intercept, what that means is the x value is 7 and the y value is 0, because that's where it crosses. And then that also means this. Okay, so I'm just going to take the first one. I'm going to use these values. This is another coordinate. It's nice that it's the x-intercept, but it doesn't matter. We can still use it. This is the x value, and the 0 is the y, or you can think of it as the f at x value. Okay, so we're going to replace f at x with that 0. Okay, and we're going to replace x with the number 7. So replace x with number 7. Everything else will stay the same. Is equal to a. Okay, 7 minus 5 squared minus 12. Did that substitution make sense? Okay. So now that I've done that, I work out some BEDMAS to isolate our letter a, because a is what we're looking for. So 0 is equal to a. This becomes 2 squared minus 12. Okay. 0 is equal to, that becomes 4, and 4 times a is 4a. You're okay with that?
Yeah.
Okay, so 4a minus 12. So now we isolate a. When I bring 12 to the other side, what will it become?
Positive.
Positive. And positive 12 and 0 is just 12. Is equal to 4a. How do we get a by itself?
Divide by 4.
That's right. We divide by 4. So our a value is going to be equal to the number 3. Great. So now to build our equation, okay, we'll rewrite it down here again. F at x is equal to the a value is 3. Our h value is 5, or negative 5, and negative 12. So there's our vertex form. Oops, sorry, I'm all over the page there. That's good. Let's do the other one, since we can. F at x is equal to a, x minus r, x minus s. So build them both together, r and s. R and s are these values here. It doesn't matter which is r, which is s, we can plug them both in. So f at x equals a x minus 7. Okay, just like that vertex form, that negative is kind of flips our sign. If this had been -7, it would have been +7 in the bracket. Okay, and then x again minus 3. So we plugged them in for the r and the s. Really good. There's nothing to really simplify. We need another coordinate, just like we needed another coordinate for vertex. In factor form, we need the 2 x-intercepts and another coordinate. So think of it like for vertex form, we need vertex, 1 more. Intercept, we need 2 x-intercepts, okay? Or the 1 if there is only 1, but we need the x-intercepts and another coordinate. But we have another coordinate, the vertex. Again, though it's special, it doesn't matter. We can still use it. The exact same way we used it in the other one. This is an x value, and this is an y or an f at x value. So we replace both x's and the f at x. F at x we're going to replace with -12, okay, is equal to a is unknown. The x value, okay, we're going to replace with 5. Is that okay? Okay. And then same idea again, 5 minus 3. Okay. And now the goal is to isolate a. So we work these out. This means a times whatever this is times whatever that is. So -12 equals a. This becomes -2. This becomes +2. There's a little trick there that if you built the vertex, if you put the vertex in your x coordinates, these two should be kind of opposite operations of each other. Okay. -2 times 2 is -4, and -4 times a is -4a. -12 is over here. How do we get 4 or a by itself?
Divide by -4.
Divide by -4, and what do we get as an a value?
+3.
Yeah. So if you notice, the a values are actually the exact same. Okay. And if you take your factored form to a point where, so this is our a value now, 3, x minus 7, x minus 3. If, whenever you're in factor form, just as a side note, if there's only a coefficient of 1 in front of both x's, the a value will be the same as the a value in the vertex and the same as the one in the standard form. Do you know how to take both of these to standard form? It's essentially just a FOIL or distributive property, however you want to call it. Okay, I won't go into that because this was already long enough, this idea.